Hi there. I'm here to talk to you today about how GraphQL makes your APIs better, and really the revolution in efficiency and real-time performance that it brings. My name is Michael Watson. I'm a developer advocate here at Apollo, and honestly, I'm obsessed with GraphQL. I've been working in the space for about 6 years, and I've seen hundreds of deployments into production. And I'm here to talk to you about that today, right? So GraphQL makes your APIs better. And honestly, that's kind of a really big statement to make, but I truly believe that. And it's my goal today to tell you why I think that, and hopefully by the end of this talk, you'll start to agree with me as well. Before we jump into all that, what is GraphQL if you're not familiar with it? GraphQL is a spec, it's a query language that really describes how to query, mutate, and subscribe to data inside of your graph. And I like to break this down and think of it simply as queries is really, I want to fetch data, mutations, I want to change, create data, and subscriptions is all about real-time data. And the nice thing about GraphQL and why client developers love it is they just need to select the fields that they want to request. And whatever fields they select, whatever fields that are part of that request, the GraphQL server is going to fulfill that and populate all the data that they need, and it's just only the data that they requested. Now, you might also hear a lot of like REST versus GraphQL. Does one replace the other? Is one better than the other? And to be honest, I've seen them used successfully together in plenty of production deployments. And it's a common migration pattern to actually, put GraphQL over your REST and start to migrate in that area. But they work together, and at its heart, GraphQL still is just REST. It's a post request where that GraphQL operation is actually in the post body of the request. And it also supports things like GET requests, where you could do what's called persisted queries, where you create a hash, and that ID represents a given operation, and that's encoded into the URL of a GET request. And you can start doing interesting things like CDN caching and lots of stuff there. So let's get back to how does GraphQL actually make your APIs better? And what's wonderful about GraphQL, it gives a great developer experience, but there's some immediate benefits you get right outside of the box. So like if you put GraphQL over your APIs today, right off the bat, you're going to get a clear observability and really understanding the usage of your graph, right? You have one source of truth now to understand, are those investments paying off for what I'm putting into my graph? Faster application development. No one is blocked on writing code for APIs anymore. Now anyone who can write a GraphQL request can add some additional fields and start supporting that new feature, new functionality. And of course, it makes your APIs better with just more capabilities. So if you point GraphQL over your APIs, you immediately get access to things like real-time with GraphQL subscriptions, new advanced features like at defer, which is a new directive coming to the spec. And you can do a lot more things and get a more performant query execution path versus some handwritten BFF code, because we now actually have a query plan execution that can happen inside of this. And at the heart of all of this is what we truly care about of what we're trying to build. And that's a delightful experience for our users, right? And that's who we love, and it's all about them. So before we dive into kind of those pieces of GraphQL, why it makes your APIs better, let's talk about like how we got there and that initial dream state, right? When we first started out, we had our website, our API, everything was really simple. We could make those changes, very simply to the front end, back end, everything was great. And things start getting really successful, and then next thing you know, we have a mobile application, which is really exciting. Things have grown, we've been so successful that now we have this mobile app. But maybe they needed something a little different, which started to cause the need for maybe them building their own API. And maybe that API starts to call the website's API because that's where they need to get that data from, right? And it starts becoming where they maybe are consuming multiple GraphQL APIs. Or maybe they even took a BFF approach, a backend for front end, where now there's a mobile backend, there's a web backend. The mobile backend might make requests to the web's backend to bring everything together, but now that client is just making one request, right? But I want you to think about what happens next, right? Maybe you have a new watch companion app that is implementing one of these new features from mobile, And so how did they get that? Does this new API pop up? Is that new API maybe calling the mobile APIs for that? What about AI? Maybe there's a large language model that your team is implementing, and that's going to give some new AI capabilities. And if that's successful, then maybe now it needs to be in the website also, in the mobile app. Like, when does it stop? And is there an architecture that better suits us for this? Now, this architecture right here is what we've seen proven at scale with our customers and large enterprises. And that's having a router in front of multiple GraphQL APIs that's able to orchestrate across the business. And we've seen this from companies like Wayfair and Intuit and T-Mobile and US Bank and many others that have been successful with this architecture. And one of the things that's really important about this architecture is where we're bringing together GraphQL into our existing APIs, and we're using Apollo Federation to combine those APIs together into what we call the supergraph. And the supergraph is what we're able to provide to the router to understand how it can execute requests across our graph based on an incoming request from the client. And the best part about this is Apollo Federation actually supports 40 plus different languages and frameworks. So you can write your GraphQL APIs in whatever language you want. Now that we have this combined supergraph, not only can we intelligently execute queries and operations across them, we actually now have an architecture where all we need to do is add more GraphQL servers into our infrastructure, and everyone starts getting access to that. It's just GraphQL for everyone. So you've probably worked with an API gateway before. The router is kind of like a GraphQL API gateway. The source code is available and free for anyone to use and to host. You don't need an Apollo account or any GraphOS license to use that. And the best part, since the router just works with GraphQL schemas, it works with those 40 plus language frameworks. So you can build your subgraphs in anything that you want. So if you're out there using .NET, maybe you're out there using Java, well, there's solutions for you to bolt on GraphQL for your ASP.NET Core app or your Java Spring Boot app or whatever it may be. Now, the router provides a lot of benefits, and at the heart of it is the observability, being able to understand how is the API, the data of your organization being utilized. And that should go to a granular level where you can understand an individual field that's being selected. How many times is that actually being used and what rates? The best part about the router too is it's just GraphQL for all. It's the same GraphQL endpoint that all GraphQL developers would expect. And new things come out in GraphQL as far as the spec and get supported there, everyone gets to take advantage of that. And anyone who can write a query can now start interacting with your graph. And Homer Simpson, he could write queries. Anyone could write queries. It's really that simple. He would be a query pro in today's world. Of course, real-time is a really important aspect of the router. Every modern application, there's more real-time experiences that are being built into them. And the router needs to be able to handle that along with the other data sources within the organization. And of course, more efficient query execution. No longer do we need to have the days where I might be writing code from my mobile backend to go talk to my web backend so that I can get that data that's already over there. Now, the router is able to actually create a query plan and execute against that of whatever data is within the organization and inside of my graph. That gives opportunities for things like caching, whether that's specific parts of the request or maybe caching those query plans, or advanced execution features like at defer, which we'll cover in just a bit. Of course, security is a big aspect of any infrastructure that you put together, and the router has security built in by default. There's a lot of things that maybe seem unknown about the security of GraphQL, but this is an opportunity for a strength. And we have the opportunity to put security controls and things in place around our router and an onion architecture there that give us confidence and also make it where all those client developers that are fetching data from your organization all benefit from the same security implementations at that routing layer. And of course, it's free to run and it's battle tested. Those companies I mentioned, Wayfair, Intuit, US Bank, they've all been successful with this architecture and the router and at scale. So we're not talking about just a couple of requests. We're talking about production scale that it's been battle tested with. So today you're going to see a lot of different examples, and all of our examples are going to be based off of the Apollo Spotify Showcase demo. It's a recreation of the Spotify web app, and it's all available on GitHub, and it uses the Spotify REST API. So it's a great example of kind of upgrading a REST API into this GraphQL space. This is the architecture that we have for the deployment. We have the website that's deployed in Netlify. Both of our GraphQL APIs are deployed in Railway along with our Apollo router. And then we have GraphOS hooked up into it. So you'll see some GraphOS examples that are all layered into this. And you can even see the schema usage, the usage reporting in this architecture. There's a lot more to it. So the first thing we talked about was the observability. So having the router route all of your GraphQL traffic now gives us a central point to understand the usage, those fields that are being selected in each one of the operations, right? With GraphOS, this is Apollo Studio, the web interface for GraphOS. We actually take usage reporting from that router to understand, what is the shape of operations that are being executed for your graph. And we can now understand down to a field level, an operation level, a client level, how is our graph being used? So when you add that new field that's associated with that new feature, you can now understand, how many times that got used. Or maybe if you have a chain of operations for a workflow that's in your application, understanding maybe where users are getting caught up because, maybe that third operation isn't being executed as often as the second operation. Now, I mentioned GraphQL for all, right? And really, writing the query is at the heart of GraphQL. And client developers just want to be able to write that query and execute it. And so writing that query is a very important piece. This is Apollo Explorer, which is the kind of a sandbox Explorer experience for GraphOS and how you can understand what data you can consume from your router. And it works very simply. It has the ability to integrate things like OAuth, it has the ability to run things like subscriptions and everything in between, right? So everyone now has one place of how to consume data from the graph and how to get started inside of that graph. Now, diving a little bit into real time, it's something that seems so simple on its level. We just have this little second that's kind of ticking up as this song plays along, but the reality of implementing something like that can be very challenging, whether you're handling it inside of your React components and progressively loading that information, or creating something on the back end. But with GraphQL subscriptions, it makes it really easy for client developers to take advantage of this real-time data. And so the client developers really just get to write their operation, right? They just write the subscription like is described in the GraphQL spec. And then the router generates a query plan based off of that and executes that request. And that might include making additional requests to downstream services to fulfill the data for that subscription. It's all kind of taken away from the client developer. They don't have to worry about it. They just write that one request. And they just start getting the data back as they'd expect, right? So just as any way they'd want to use that subscription, it doesn't matter if maybe it's coming from multiple GraphQL servers downstream. To them, it's just one GraphQL endpoint. And I think GraphQL has been doing a really good job of pushing the boundaries of real time. There's a lot of things that have been popping up in the spec lately around @defer, @stream, and new protocols inside of subscriptions. So WebSockets have been around for a long time, but you have this persistent connection, and the scale of it has some challenges. We recently put out an HTTP protocol that describes a way for a router to have a callback URL where subgraphs can actually publish changes. And we actually implemented this inside of that Spotify Showcase demo, and we saw a really big performance improvement from that. And so I want to take a moment actually to talk about that protocol and kind of how it works. So at its core level, there's an incoming request from a client for its subscription. That request is going to come into the router, and the router is going to have to make its first request to a downstream subgraph. And it's going to register that subscription with a callback URL and a verifier, so we can verify that the data coming into the router is from a trusted source. When new data comes into that subgraph, the subgraph's going to take that new data and it's going to publish it to the router. And it's going to use that callback URL along with the verifier to publish that information. Now, the best part about this is there's no long-lived connection any longer, right? Now the subgraph is only publishing updates as it has it. And finally, there might be a situation where maybe other data is. That previous operation we saw a couple slides ago, that was a federated subscription. And there's actually some additional data that needs to be updated after that initial event message was coming in. We call this federated subscriptions. And the router can handle all of that. And the client just gets chunked that information as they see. All right, so federated subscriptions, really cool. And the client developer doesn't have to worry about it at all, just as a normal subscription to them. Now, it's pretty common to get requests about progressively loading things in our application. And it's kind of like, hey, there's this data that's on the page, and we don't actually need all of that data to interact with that page. So how can we maybe defer some of that or not wait for some of that information? So this is actually the tracks page from the Spotify Showcase app. And you can see there's information about the artist, the top tracks, and then of course there's the play bar and the other states in the application. But really, we don't necessarily need all the information on this page to display the page and let the user start to interact with them. This is the query for that exact route. And you can see that there's some aspects like this top tracks. Doesn't need to be loaded for the first interaction, right? Now, it'd be great if client developers had the ability to hint that, hey, I could actually wait for this information. So there's a new thing coming to the GraphQL spec called At Defer. It's a new directive that's just about to be introduced. It's been in the working group. A lot of companies have different implementations with it. But the idea is the client developer can hint to the GraphQL server that it could wait for some data to actually be incrementally loaded. And our example here, we have that same operation on the screen. All we've done is we've extracted the artist and the album details into its own fragment. But you can see it took about 100 milliseconds to fulfill that request, and it just went to our one GraphQL server. Now, using at defer, we can simply add that for that fragment and tell the router, I can wait for this, incrementally load this information whenever it's ready. And what that actually does is the router understands that hint and generates a different query plan. And you can see it's actually breaking that request into two requests. And it doesn't matter that it's making a request to the same subgraph. It might be multiple subgraphs, different subgraphs. It's going to be generated by the query plan based off of what is the most optimal execution for that given operation. Now, the great thing about that is the first load of information. You can see here loaded in about 26 milliseconds. So we shaved off about 75 milliseconds from our time to first interaction in this example with at defer. And we didn't have to write any implementations on the back end, the subgraphs. It all just works. When I say GraphQL for all, it also means, as these new advancements come into the GraphQL spec, as real-time advances, as stream gets introduced, having that support at the routing layer means these downstream subgraphs don't have to do anything to implement and support something like that, but they get to take advantage of those benefits. Same thing for the client developers. Client developer can now just hint in that at defer. They don't have to worry about, does my backend server actually support at defer? It just works for them. And of course, the rest of that data is going to get chunked in and incrementally loaded. And you can see that the overall request took just about the same time for that to work. So let's talk about the elephant in the room with all of this, though, right? It's the security elephant. And a big part of, if you haven't come to GraphQL, you haven't done GraphQL yet, maybe you're a little concerned of like, what are the things security-wise that I need to be thinking about? And there's a lot of stuff in there, right? How am I going to do authentication, authorization? How am I going to deal with bad actors that maybe have malicious queries or queries that are too complex that might bring down my graph? Or the belly of the elephant, the things you just don't know. But GraphQL's been around for a while, and there's been a lot of solutions, a lot of things that have been built and put out in the industry to address these problems. And I mentioned this being a successful architecture that we've seen plenty of companies build, and they use this as an opportunity to build those security controls into that control plane and what their router is. Right, so authentication is a great example. Just recently in Apollo Federation 2.5, we released at authenticated and at require scope. And this basically describes a way for a graph router to be able to take an incoming request and actually go out to an external process. And for example, identify a user's token, make sure that is a valid token, and then also return the user's scopes. And then the router can take that incoming query, generate a query plan, and actually prune off parts of the query plan that a user doesn't have authentication for or maybe doesn't have the right scopes for. So now you're actually blocking your requests at the routing layer versus downstream subgraphs, which is kind of what everyone wants. Now, here's one aspect that we've seen, I've seen almost every production deployment, which is persisted queries. And really the idea here is the operations you have internally at your company, those are important, and you should probably keep a list of all those operations and make sure they're up to date. And that's really what persisted queries is. It's a list of all of the operations with a hashed ID for those operations within the organization. And it presents the opportunity to start optimizing and doing things around persisted queries. And that can go into things like caching, that can go into things like I had mentioned about query plans, a lot of interesting stuff that happens, but one of the most common use cases of persisted queries is actually safe listing. And this is with the idea of you have your internal clients, your internal traffic, they're pre-registering their operations, saying, this is what I'm going to be running in production. And you can actually lock down your production deployment to only serve persisted queries, which is really nice. When you think about your application, what you have out there, maybe you have your website, your mobile app, maybe you have a customer service application that's inside of that infrastructure, but you own all of those clients. You own all of that development inside of there. So you want to make sure that only that traffic is what can be executed inside of production. Persisted queries makes that really easy. And if you have a public-facing graph, well, now you can actually just run the router with the same supergraph in two modes. One with persisted queries enabled, that's serving all your internal traffic, and one where persisted queries is disabled, and that's what you use for your public external API. And now you can scale those resources differently and not worried about the public thing taking down the private thing. Now, you also want to think about the operations that can be executed, especially if you have a public graph. What are the things you maybe do to limit that? One of the most common things that has been out in GraphQL for a long time is depth limiting. What level of depth someone can select into an operation. But there's other things you should consider as well. Like how many root query fields maybe someone is able to select inside of that. Or how many fields can someone alias inside of a given query? That's an important aspect you might want to control. You built the graph as a representation of what you want. How many times do you want someone maybe to alias certain fields? Or what's the height? How many fields inside of a given type do you want to let someone be able to select into? All right, so there's various ways you might want to limit operations that run in your graph. And the best part is this is all just router configuration, right? So having these things and these controls implemented at the routing layer really helps with all of that. So as we wrap up today, there's two things I want you to remember. One, GraphQL makes your APIs better with advanced features, real-time, and more efficient query execution. And two, you can add GraphQL onto your existing APIs today. Like seriously, you could just add on a /GraphQL route, and you can start having the architecture of what I've described in this talk today. And if you have questions, come by the booth, come talk to me. Join us in our Discord. I'm more than happy to help talk through your exact situation, and let's figure out how can we help make sure that GraphQL is giving you those benefits and making your API better. And of course, if you want to learn more, we have lots of resources. Odyssey is our set of tutorials. I think that's a great set of learning materials for learning GraphQL, learning Federation, GraphOS, more depth of what I've talked about today in this talk. There's also our documentation for the router for GraphOS. That covers a little bit more depth in some of the items I talked about today, things like HTTP callback protocol. We have a lot of docs and stuff in there about that. And of course, the GitHub link for this demo, everything that's in here. Like I mentioned, if you want to come by the booth, we can also recreate this demo for you and send you a URL that you can go check everything out in there. And with that, I just wanted to say thank you so much for coming to this talk, listening to everything I had to say. The QR code you can see here on the screen, that's actually for our Discord. We'd love to see you inside of there. Myself, my team of other developer advocates, we're in there talking with our community and trying to help people be more successful with GraphQL. So hope to see you there, and thanks for coming.